Hey, this is Andrew Brown, and we are taking a look at what is RAG. So, RAG stands for Retrieval Augmented Generation, and its access patterns. I put extra emphasis on the S so you know that it comes in many variants for retrieving external data to inform an LLM agent prior to providing a response to the user. I should have also highlighted the word augmented because that is what it's doing. It's augmenting the LLM with information. Okay? So a very common RAG pattern that is representing information as vectors in a vector database and then using a search engine to vectorize a search term to return relevant documents is what you're going to see most often. Now, you don't need a vector database to produce RAG. Again, RAG is just about getting external data from the LLM to help it be a smarter based on its limits of knowledge. Okay, but let's look at this example so that you have some basis of RAG and the most common way that RAG is used. So on one side, you have your data store. This is going to have the documents you want your LLM agent to have access to. On the other side, we have the agent. So here we're representing it as GPT. And then in between it, we have our vector store. So a vector store is often a document database. Those are really good at storing vector data. So MongoDB is right now the leader in document databases, and it makes an excellent vector store. There are many options. But anyway, the idea is that you have this thing, which is vector data. And vector data is really good at correlating relationships between things. So the idea is that we're going to take our documents, and we're going to use an embedding model that is going to turn it into vectors. And when you see the word embedding, you should immediately think vectors because embeddings create vectors, okay? And all it's doing is it's just taking your data and breaking it up into vector data and determining how likely something is related to something else. So the idea with this embedding model, maybe we'll make another slide for this, but the idea is that you have all different ways to embed your data, to represent your data as vector information. And the vector is just basically the distance between similarities of your data. Okay, so you could make it so that similarities are based on how similar the word is, based on the understanding of what the word is, maybe the length of word, you know? So there's all different types of ways you can embed your vectors. We're not going to worry about that right now. But once we have them in our vector store, now we want to use that vector store to determine what documents to return based on what the agent wants. So imagine that the agent provides a search term. So maybe we are looking for apples, right? Like tell me the best apples in the world. So it's going to take that search term, and we're going to turn that search term into vector data because in order to search the vector store, we need vector data to search it against. So the embedding turns it into vector data, and we give that to our search engine. So in this case, we have Lucene, which is an open source engine. A lot of search engines are based off of Lucene. And so it's going to use that vector data, and whatever means it wants to search the vector store, it might have other algorithms in play there that it's going to utilize along with the vector data to retrieve vector points. And that stuff is either going to be stored in the vector store or it's going to be pointing to the chunks of data that we want to return back to the agent. So that data is going to then be returned and the agent's going to do something with it. This does not scratch even the surface of RAGs. And I wish I had more time to talk about it. Not in this course, but in other courses, like maybe when I do my GA Essentials course, I will cover RAG in its entirety, which if that's even possible. And the reason why it's so hard to cover is because RAG is, again, it just means getting data externally. So instead of this vector store, this could be reaching out to the internet, like using a search engine, like a Google search engine to grab information. The agent is explicitly saying what it wants, but there might be an implicit way to do it. There's different algorithms that can be used. There's different embedding models that can be used. So there's a lot that goes on in here, but don't get scared by the word RAG because all it just means is access patterns for retrieving external data. Another interesting thing, which we're not really representing here, is how the data gets inserted into the LLM agent. Okay, we'll talk about that in 2 seconds here, but return information is directly inserted into the context window. I guess it was right away. The context window of the LLM. And the context window is just imagine the information you're going to provide the agent, the LLM, to produce information. So literally, we're taking the text and we're inserting it, the raw text, into, imagine you're typing to an LLM, like telling it stuff. It's like you're copying and pasting it right into the box and providing that information directly there. And so for me, I was confused for the longest time because there's all this talk about vectors, and I thought RAG had to be related to vectors, and it doesn't necessarily have to be. But you don't feed vector data to the agent, to the LLM, right? You're feeding the raw information, just as if you were to copy and paste it. Okay. And look out for these embedding models, because sometimes you'll see it'll be like, here we have Cohere as an example, but Cohere, they have LLMs, a family of LLMs, and so they'll have like Command R, and then there'll be like Command R embeddings, and that embeddings model, all it does is it vectorizes your data in a particular way. But if you are going to embed, right, you want to use the same embedding model for searching as you are for storing your data, because if you use a different vector embedding model, it's optimizing that database, that insertion to that database, a different way than the other one. You're going to just get weird results. So make sure the embedding model is the same on both sides. So a RAG access pattern doesn't require a vector database. It's just that is the most common way that RAGs are used. What's important to remember is if you have to fetch external data, then you're utilizing a RAG. And while this looks very involved, like you're programmatically doing a lot of things, often RAG is being implemented by AI services, so you're unaware of the underlying moving parts. So if you use ChatGPT and you've uploaded documents, you're using RAG, right? It doesn't look that way, but it's there, and they're not using that term because they're trying to keep it customer friendly for some services. So hopefully that gives you an idea of what RAG is, and I'll see you in the next one, okay? Ciao.